In this video, we're going to learn about the law of reflection. In optics, we're going to study mirrors. Mirrors are very, very smooth surfaces that reflect light. So light hits them and then bounces off of them. And so there's two main types of mirrors we're going to study. We're going to study the plane mirrors and the curved mirrors. The plane mirrors are the flat mirrors that you often have in your washroom. And then the curved mirrors are mirrors that curve either inwards or outwards. And so they can be either concave, like looking into a cave, or convex, which curves outwards. And so the first bit of optics is going to be about studying how plane mirrors form images, meaning how do you see things in plane mirrors, but also how concave and convex mirrors form images. But before we can do that, before we can study mirrors, we have to be able to understand the law of reflection, and we're going to focus on that today. Just if you want to see examples of concave and convex mirrors right before your eyes on the same device, you can grab a spoon. Take a look at the spoon inside and take a look at the spoon on the side that curves outwards and see that your reflection, that you call it, now called an image in optics, will be a little bit different. So, let's try to classify mirrors based on types, based on the previous slide. So you can pause the video, try it yourself. So this first one here, after you pause the video and try it yourself, should be a concave mirror. The second one here, curving outward, should be a convex mirror. And this one is simply a flat mirror, so we call it a plane mirror. So we're going to define some terms. Here we have a mirror, a plane mirror. This is the front of the mirror, and I know that because the back of the mirror has these little lines to indicate it's a back. This is the object. The object is what's in front of the mirror. So we're looking at this tomato here. And when you see something in the mirror, that thing is called an image. You're used to calling it your reflection, but it's really an image. So here we can see the object, the pot, plane mirrors over here, and what you see over here looks like it's in the mirror here. That's the image that's made. And the reason you can see this object or this image here is because light from the object, the tomato, which comes from another light source, bounces off the light, bounces off the tomato, hits the mirror, it reflects off the mirror and goes into your eyes. Now, even though you understand reflection, your eyes and your brain don't realize that there's actually light reflecting this way. Your eyes think the light is actually coming here, that it's just coming straight in a straight line because it's how light travels. Biologically, that's how we see it. So your eyes basically extend these reflected rays behind the mirror and tricks your brain into thinking there's actually an object there, but there's not. It's just an image that's made. So it's not really there, but it looks like it's in there. So a reflected a ray from an object hits a mirror, reflects off the mirror, goes into your eyes. Your eyes don't realize that this is happening, so it extends the line behind, and then thinks that there's something in the mirror, and that's called your image. So we're going to see more on that later on, but now we're going to focus on a few other important terms. So again, this here is a mirror. This is the glass. This is the reflective surface here. The scientific symbol for a mirror is just a line like this with some little diagonal lines behind it to show the back side. But this is the reflective surface here. And so here we have our mirror. And over here we have a ray of light hitting the mirror. And after it hits the mirror, it bounces off. That ray of light hitting the mirror, that is called an incident ray. It's going into the mirror, and we draw it so that the arrow here points that it's going into the mirror. You can draw the arrow in the middle or at the very tip here. And the ray of light that bounces off the mirror, that's called the reflected ray. And the ray points away from the mirror because it's moving away from the mirror now. In between the incident ray and the reflected ray, there's a dotted line, an imaginary dotted line called a normal. It forms a 90-degree angle with the mirror, and it's always drawn in between your incident ray and your reflected ray. And the reason we draw a normal there is so we can measure angles. there's an angle that happens between your incident ray and your normal. That angle is called the angle of incidence. We call it theta I. Then the angle between your normal and your reflected ray, that's called the angle of reflection. We call that theta r. Now be careful. The angle of incidence is not the angle between the incident ray and the mirror. That's different. It's the angle between the incident ray and the normal. And the angle of reflection is not the angle between the reflected ray and the mirror. It's between the reflected ray and the normal. But the normal does make a 90-degree angle, that you can see here, with the mirror. So here we have a more 3D view. We have the incident ray hitting the mirror, bouncing off, that's a reflected ray, the arrow pointing in, arrow pointing out, the normal 90 degrees to the mirror, right in between the incident and reflected ray. This angle, your angle of incidence, this angle, your angle of reflection. So that's key terminology you're going to have to know, because we're going to use it in essentially all types of mirror drawings that we do. So there's something called the law of reflection. If you're in class, you're going to be doing an investigation to figure out the law of reflection. If you're not in class, you'll be following along with this lesson to understand what it means. But either way, you should know how to prove it using ray boxes or lasers. So there's 3 points to the law of reflection. The first point is that the angle of incidence is going to be equal to the angle of reflection. So if the angle of incidence is 65, then the angle of reflection is also 65. The second point to the law of reflection is that the normal is in the middle of the incident ray and the reflected ray. That means they're always on opposite sides. So the incident ray is on this side of the normal, and the reflected ray would be on the other side of the normal. And then the last point is that the incident ray, the normal, and the reflected ray are all on the same plane. They're all on the same surface. So let's say you're shining light onto a piece of paper. That light will bounce off in the same plane of that paper. It won't come out at you and poke you in the eye. It won't go behind the paper. It'll stay on that same paper. And the normal is also there as well. If you look at it from a three-dimensional point of view, this is the plane here. Okay? The incident ray and the reflected ray are in the same dotted box. This reflected ray won't jump out of the box and go that way, or come out this way, or go that way. It's going to stay in the same plane, and the normal is also in that plane. But the main point really of the law of reflection is that your theta r is equal to your theta I all the time. So these are the 3 points of the law of reflection, and you can prove it using ray boxes, but it's important to know these because they're going to be applicable when we do ray diagrams. So you can practice labeling this picture over here. Pause the video, try it yourself, and then we'll take it up. So after you pause the video, hopefully these are the answers that you came up with. R over here, this is a ray going into the mirror, so that's the incident ray. T, this is the ray going out of the mirror, so that is the reflected ray. S is a dotted line perpendicular or 90 degrees to the U, which is the mirror, so that's the normal. X is the angle between the incident ray and the normal, so that's the angle of incidence, theta I. Y is the angle between the normal and the reflected ray, so that's the angle of reflection, theta R, theta little r to be precise. And U is simply the reflective surface or the mirror. So you can try these practice problems as well. Pause the video, try them out, and then we'll take them up. Okay. So if angle X is 60, then what is angle Y? Explain how you know. So what we're looking for here is that if this is 60, that's the angle of incidence, then angle Y should also be 60 because it's the angle of reflection. According to the law of reflection, the angle of incidence, theta I, is equal to the angle of reflection, theta R. So it should also be 60. Well, what's angle W then? So angle X is 60. What is angle W? Well, know that the angle between the normal and the mirror is 90. So if this is 60 and the total here is 90, then this must be the rest of it. This must be about 30. So we have 90 minus 60 because this whole thing is 90. This is 60. Take away the 60, that leaves you with 30. It's not drawn to scale, so that's why it looks a bit off, but about 30 degrees. What is angle Z? Well, if you think about it, it's the same thing. It's 30 because this is 90, Y is 60. So if this whole thing is 90 and this is 60, this has to be 30. So you have 90 minus 60, 30. Next question was explain why the images below do not follow the law of reflection. Which part of the law do the pictures break? So this one is pretty straightforward. You see the angle of incidence here is 20, and then the angle of reflection here is 60. So we know that theta I is supposed to be equal to theta R, so that's why this one's wrong. Over here you'll notice the incident rays here and the reflected rays is here. We know that the incident ray and reflected ray should be on the opposite sides of normals. So if the incident ray is here, the reflected ray should be here on the other side of the normal. So it's breaking that second rule. So these are some practice problems relating to the law of reflection. We understand what it means. We can label all these different components and understand the three parts to the law of reflection. In the next video, we're going to be drawing what's called ray diagrams. I'm going to start off by explaining what a ray diagram is, and then we'll go ahead in the next video to draw some. So a ray diagram is just a diagram that shows you how light interacts with surfaces. So you basically just draw arrows and show where they'll be going and what angles they'll be bouncing off at. We're just basically drawing these diagrams here, but we're going to use protractors to draw in this precise angles at which they're hitting the surface. When we are drawing ray diagrams, we're going to represent light as arrows. The incident ray always points into the mirror, into the surface that's the reflective surface. The reflected ray always points out of the mirror. And the dotted line the normal is always going to be drawn as a dotted line 90 degrees to that mirror. So these are the general rules we're going to follow when we're doing ray diagrams. So in general, when you're doing ray diagrams, you're going to follow the basic rules we said here. In the next video, we're going to do a variety of practice problems related to ray diagrams.